Recently, a viewer requested a parametric design for a screw-on lens cap, making it easy to adjust to any size needed. First step, of course, was a little research to find out what the standard dimensions are for a lens cap. Fortunately, the online resources were readily available. This also gives me an opportunity to introduce the Fasteners workbench and the new Var Sets. If you don't already have the Fasteners workbench and want to follow along, go ahead and install it from the add-on manager. I'll have a cup of coffee while you do that. I suppose Varset isn't that new. It's been around since a little before version 1.0. Essentially, a Varset is a feature that has no shape but contains user-defined properties that can be referenced in formulas. It's kind of a lightweight version of the spreadsheet. Starting in the Part workbench, create a new Varset. The dialog that comes up allows creating properties for the Varset starting with the name. The first property will be called Thick. This will be the thickness of the lens cap. Leave it in the group base. For the type, there are many different options. In this case, we want app property distance. Other options include various electrical and material characteristics, as well as generic integer and floating point values. Property distance is the better choice since it implies a unit of measure. That makes it easier to use in formulas that expect a measurement. Set the value to 1 millimeter. Notice the little quirk in the dialog box. When you first enter the name of the property, there's nowhere to enter a value. By clicking on the type drop-down, even without changing it, the value field appears. That may not be quite a bug, but it does seem to be a bit of an infelicity to me. Also check the Add Another box. This is a convenience feature for rapid entry of multiple properties instead of calling up the dialog repeatedly. When you click OK, the property is created and you get a fresh dialog ready to add another. Once you've entered the last property, you can either uncheck the Add Another before clicking OK, or after clicking OK, click Cancel. So click OK. Next property is Pitch. This will be the pitch of the screw thread for the lens cap. Set it to 0.75 millimeters. In my online research, I found that the most popular thread pitches for lens caps are 1/2 millimeter, 3/4 millimeter, and 1 millimeter, depending on the diameter of the lens. I'll put a link to the table I found in the description for your reference. Of course, if you're making this cap for a particular lens you already have, you can always get the calipers out and measure the pitch yourself. The next value is depth, how long the thread is. According to the resources I found, this is almost always 7 millimeters, but it's easy enough to add it as a parameter just in case you end up with an oddball. Finally, dia, the diameter of the lens. I'll go with 43 millimeters. Selecting the Varset, you can see our properties show up in the data pane. For brevity in the formulas, rename Varset to V. Now go to the Fasteners workbench. We need a tap suitable for creating a metric thread on our lens cap. Odd thing with Fasteners. Sometimes when I bring it up, the icons are arranged as you see on the screen now, with drop-downs for additional tools in the class. Other times I see multiple rows for the tool icons and they're all expanded. It's quite a dizzying array of options here. Perhaps the easiest way will be from the menu. Go to Fasteners, Add Threaded Rod, add ISO Screw Tap Metric Threaded Rod for tapping holes. I have to say that's a pretty descriptive name. And there's our tap. Select it and in the data pane, set the length to v.depth. Set the first diameter field to custom. Set the custom diameter to v.dia. Finally, set the pitch custom to v.pitch. Now set the Boolean value of thread to true so that we will actually render the threads. Now back to the part workbench. Create a primitive cylinder. Set its radius to v.dia divided by 2 plus v.thick. Set height to v.depth plus v.thick. We're going to need another adjustment. The cylinder is created on the XY plane growing upward, but the tap was created on the XY plane growing downward. I'm not sure why. That's easily enough fixed. Select the tap and in the data pane set a formula for placement.position.z. Length plus v.thick. Finally select the cylinder, then the tap, and cut. At this point we have a very basic but serviceable lens cap, but it could certainly use some improvement. For one, it needs a small chamfer at the opening to make it easier to put on. Without it, you would have to align the lens cap quite precisely to get the thread lined up. With a small chamfer, you don't need to be quite so precise and it'll self-align. But it's not quite as simple as selecting an edge and applying a chamfer because of the screw thread. There isn't a single even edge going all the way around. It's going to be better to make a tool for the job and cut that away from the lens cap after. So create a second primitive cylinder. Select it and in the data pane set placement.position.z to v.depth plus v.thick minus 0.5 millimeters. Set its radius to cylinder.radius. It has that tiny bit of overlap that we want. For the moment, hide away the lens cap. Select the bottom edge of the cylinder and chamfer to 0.5 millimeters. Unlike the lens cap, this is an easy chamfer because it's a simple cylinder. Bring back the lens cap. Select the lens cap and the cylinder and cut. That gives us a nice chamfer we were looking for. Finally, purely for aesthetic reasons, select the lower edge of the lens cap and apply another chamfer of 0.5 millimeters. It just looks a little bit nicer than the hard corner and maybe even feels a little nicer in the hand. There are plenty of other customization options from here. You could add finger grips or perhaps a design printed into the cap. Just a small word of caution. Due to the fine threads, this may be a bit of a bear to print on an FDM printer. At the very least, the first time it's put on the lens, it's going to be a bit tough to tighten as it runs the threads in. It may actually come out a little better on a resin print. Certainly a laser-sintered powder bed print would work nicely, or machined out of aluminum. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.